on test scores. Huge difference. We got to take advantage of the things I'm asking you to do. I try not to do a single thing that will ever waste your time, okay? Now, for those of y'all stressed about grades, look, especially juniors, after we finish the AP exam, you're going to have one final project for me, and that project we're going to work on in class, and the whole design is to help bring up your grade. It's a summary of everything we have learned, but you're going to get support in class from me, and you're going to work on this. So, you're going to be fine as long as you do what I ask you to do. I think, Logan, you had a really strong test as well, changing up the way we maybe study, things like that. I need you to do what I'm asking you to do, and I promise you, you'll learn a lot and you'll be better off. But we may need to change our mindset about some things. But let's look at this review. So the distribution of monthly rent for one-bedroom apartments in a city is approximately normal with a mean and standard deviation. A graduate student is looking for a one-bedroom apartment and wants to pay no more than $800 in monthly rent. Of the following, which is the best estimate of the percent of one-bedroom apartments? Now, this is one you got to know, because this is something that's going to show up for sure at least once or twice on the multiple choice and on the free response. What's the first thing I need to do? I would say even before I do a z-score, I'm probably going to convert to that in a second, but I'm going to start that normal curve. Now with this, I could put what as my mean? I could put 936, but I heard someone say z-score. I think that was Deacon.
Yep.
I'm going to make my mean 0 and my standard deviation what? Okay. It's going to make things easier long term. Okay. So z-score. How do I calculate the z-score in this situation?
Value minus mean.
So when you say value, am I using x bar here? So here's what I want to point out, and we need to be clear on this, because this is something that took me a while to wrap my head around. There are some times when we use this formula, so value minus mean divided by standard deviation, and there's some times when we use this formula, which the mean of the sample means, remember that is just mu divided by the standard deviation of the sample means, and that's my standard deviation divided by the square root of n. Which one am I supposed to use here?
The first one.
Why is it the first one?
It's not a sampling distribution.
We need to recognize, am I averaging multiple apartments? No, it's one apartment, it's not a sampling distribution, right? It's just x minus the mean divided by the standard deviation. So, I assume some of us did that calculation. What did we get?
Just about 2.2.
Negative 2.2?
Yeah.
So negative 2.2 is roughly here. Which direction should I shade? Left? And so what do we do once we have our normal distribution? We have our z-score. Use the calculator. So we're going to go to menu and then where? Distributions. I would say, Peyton, what type of distribution are we looking at here? How about you pick up the calculator and you look? When we look at that menu, we go to distributions or statistics, or no, probability or statistics, either one. And then distributions. Which type of distribution are we looking at? Normal what? CDF? Peyton, do you agree with that? Why do you agree with that? No, sir. That is not enough information. We got to be more clear with it. Why is it normal CDF? Click on normal CDF. What does it ask for there that should tell us normal CDF? Huh? Has a lower bound and an upper bound. That's critical, right? Lower bound and upper bound. And also remember, a normal CDF is trying to find a what? Area, right? Normal and CDF. Do we ever use PDF? No. That's a probability density function. It's just the height there, I believe. We want a normal CDF. We want the area under that curve. And so what was the area under that curve? So 1.3%? I will point this out. I didn't have to actually do any of that work. Do you know why?
Empirical.
Empirical rule. What percent of my data is between 2 below and 2 above? 95%. So at what's below 2 below? 2.5%. But we don't even have that full 2.5%. So what was the only answer possible? Hey, right, so don't forget, you can use the empirical rule to visualize and think about these things, take advantage of that, because that could have been quicker. You can do the normal CDF for sure, and that would have gotten you there accurately, because we don't ever want to miss a question like this, but I do want to point this out. If I was doing this, I probably wouldn't have thought about the empirical rule. I probably would have done the z-score, but I would have drawn it out. I see way too many people that have blank information there and just have an answer circled. Draw it out. Write out your ideas. It's going to help you focus your attention. Number 8, the heights of adult. Well, first off, what are your questions before I continue? We got our notes updated so that we can improve our understanding. Peyton, you got your notes updated? Really? Number 8, the heights of adult women are approximately normally distributed about a mean of 65 inches, standard deviation of 2 inches. Rachel is at the 99th percentile in height for adult women. Then her height in inches is closest to what? How are we tackling this?
Draw it out.
Okay, draw it out first. What information do we have about Rachel?
She's at 99th percentile.
What does that mean? It's like, obviously 99 to be way over here, right?
Yeah.
So what are we going to do though?
Shade
Shade to the left. Remember, a percentile is everything that is less than. Okay, so what do I need to find now?
At this point, you need to find the number of standard deviations above the mean.
Right, I have the area. I need the z-score. What do I need to do for this, Peyton, to find the z-score if I already have the area? How's that going to change things? Okay, how? Where are you going to go on that calculator? I would highly recommend everybody pick up the calculator if you haven't already done it once. Where are you going to go? Inverse normal? Peyton, why would it be inverse normal? Because you, huh?
You're doing the inverse.
Okay, so that's what we need to recognize, right? We still have a normal distribution. I'm looking for that boundary. I have the area, so inverse normal. What is z then? No. What is z? What do we put in for our mean and our standard deviation? 0 and 1, right? So what's my z? No, that's the area. 0.99 would be my area. But once you do the 0.99, what do you get for the area?
4.65.
No way.
2.23.
Why is 2 times on there?
Yeah, I was gonna say. So be careful with that. So hey guys, so I do want to point this out, right? So this is something you need to logically think about and not just put into a calculator, because it's very clear where also made the mistake. But he told me a z-score of 4 point something. Why should you know instantly that something went wrong? Because it's crazy high. It is above what? 3, right? That's something we would want to recognize. So what does it come out to be? 2.32. Okay. Equals, I don't know her height, minus, what's the mean? 65 divided by 2. So solve that equation. So I just multiplied by 2, add 65.
69.6.
There we go. So 69.64, 65, so 70, right? How'd you do it?
Drew the normal graph, and
Did you just do the
rule?
Okay.
And I was like, well,
It's got to be close to 3 standard deviations above.
2 standard deviations above gets you to 69. So
Okay.
it wasn't gonna be.
So it had to be a little bit more than 69.
Yeah.
Works as well, right? So does the empirical rule help? Okay. So I wasn't saying that's the only way. I'm just showing you this one way. Because here's the thing I will say, Bryson. That works well for multiple choice. Will that work for free response?
No.
So that's something we always want to keep in mind. Great for multiple choice, but keep in mind that free response. If it's also not clear, then make sure. Now, let's look here at number 9. I think some of us got a little thrown off by this one. Just looking around, some wild faces. So we got a sampling distribution of X bar, and it asks for which of the following is the best estimate of the standard deviation of the population. What'd y'all think?
Like some algebra.
Maybe, but what were we naturally thinking? Huh? What are you saying, Haley?
Oh.
15?
That's so simple.
But pay attention. Ooh, it's not 15 though. Hold up.
It's not 15.
Hold on. Y'all need to reread your graph.
Because that's the same.
Because that's the standard deviation of the sample mean is 15, right? So that's a good thing to notice. But what do we want to know? The population, right?
Well, you gotta plug into
So, how are we going to find the standard deviation of the population?
with a little formula sheet.
What's the little formula sheet?
The standard deviation of the.
Parameters of sampling distribution.
So the standard deviation of the sample mean divided by what? And what is n?
Or 25, 15.
Right? N was 25.
Yeah.
So that's going to just give me 5,
15 times 5.
right? And so Haley, great note on the idea of that 15 right here, right? But we have to be careful with the notation, right? The sampling distribution is the standard deviation of x bar, right? And that's going to apply to what we're learning right now, which is why I included this multiple choice question.
How do you
So remember, the standard deviation of the sample means is the population standard deviation divided by the square root of n. That's on the formula sheet, right?
That is correct.
So be careful. You looking for where it is, Bryson?
Yes, sir.
Yeah. Hey guys, I need you to have your formula sheets out every single day this unit because we will be using that to drive some of our thinking. Does anybody need me to reprint? Quickly. We find it? Okay. You're not dying. You'll be okay. Yes, Joseph. Oh, Joseph, you need me to print it out?
Wait, I'm still lost behind.
Does anybody else need me to print it out?
I just want to know where it's at.
It's,
So tired.
yeah, for one population of
Oh, so
things,
it's pretty good.
standard deviation.
And all my girl.
Okay.
But we had to wait by
Why are you
7
I will have to print this out for you later, Joseph, because it's taking a butt lunch. Alright, but look guys, look. Sampling distribution for means. You need to identify what type of variable you're dealing with. We're dealing with means. How many populations? 1. And so we have the mean of the sample means and the standard deviation of the sample means. So that sampling distribution, right, is on the back side always, okay? So pay attention to this formula sheet. We're going to be using it over the next couple days.
So how do you use that?
Huh? Didn't we just do the standard deviation of the sample means was 15? We don't know the population standard deviation,
Yeah, got it.
right?
Yep.
Okay. So that is the majority of that current unit, or that first unit on those ideas. We're going to do, what is it, experiments and observational studies next. One thing I do want to point out, because I was talking about this with Tyler and Deacon this weekend, how do we, so first off, hey guys, because it wasn't really a part of this, but what's the, what do you need to keep in mind if you're asked to analyze data on the free response?
Stay,
Analyze data, not a hypothesis test, not an inference procedure. So we need to cuss the data. Okay, we got to know what it stands for. Cuss the data in what? Context. What does that C stand for? Center. What are the measures of center we could talk about? Mean and median. You can also just say the center of the data, but mean and median are the most common ones, right? So what does the U stand for? Unusual aspects. What could be an unusual aspect? Outliers. Not skew. Gaps. Where would skew fall? Under shape. So under shape, we could have skewness or what? So approximately normal, symmetrical, bimodal, or,
Uniform.
okay, it could be uniform. Remember, uniform is different than unimodal, that's what I was looking for. Remember, a mode is the most frequent, so unimodal, one hump, one most frequent, bimodal. And the last one is what? Spread. Oh yeah, flip, shape, and spread. What are the measures of spread that we're usually going to talk about?
Standard deviation.
So standard deviation. What does standard deviation go with? Mean or median?
Mean.
Mean, right? That goes with mean. What other measures of spread?
IQR.
IQR, the interquartile range, that goes with the median, and box plots, but that goes with median, and then we also can use range. Okay. So, little recap there of those things. We're gonna, oh, and then IQ, or outliers. How do we calculate those outliers?
It's 1.5 times the IQR plus or minus the
So it's
third quotient.
So it's 1.5 times the IQR beyond the what?
The outmost quartile.
The quartiles, right?
Yeah.
So if it's an upper outlier, it's going to be Q3 plus because we're going to go above it.
Yeah.
And if it's beyond that, it's an outlier. What if it's but on the lower end, it's Q1 minus 1.5 times the IQR. So remember, that's how we calculate those fences. If it's beyond the fence, it's an outlier, right? All right. Quick note about the test. Overall, best job we've done on multiple choice. A lot of really strong multiple choice. I'm going to need you during advisory Wednesday so that we can talk about that free response. The vast majority of you should redo your free response.
Yeah, I'm good.
Okay. So, greatest multiple choice I've seen. Even those of y'all who traditionally do strong on the test, you miss some important details on the free response. So everyone in here during advisory for free response. Mock exam. We need to do a mock exam, but we also don't have a ton of time. So here's what I'm going to do. I am going to offer a Sunday afternoon mock exam. And I know it's like, man, that's the weekend, Mr. Kenny, to incentivize free bonus points for just showing up and doing the mock exam. I don't usually do that. I will negotiate. My plan right now, if we can make it work, is the third Sunday of April. I think that comes out to be the 21st. Yeah. So look to see if you have conflicts. See if there's a time that you can't do. But I can do early afternoon, I can do mid-afternoon, or closer even to the evening, okay? So listen, it's not ideal, but also I want to make sure we get that mock exam in, and by that point we'll have the majority of our content finished. So don't stress about it, but find out if there's a time you cannot do. So, especially for the juniors, remember I said we're going to have a final project, right?
Oh, I couldn't hear you. You were
Yes.
speaking.
The project would be our like final exam.
Correct.
But it'd be in the
So we would
afternoon.
have a final
The test?
exam.
Correct.
Just like-
Yeah, that's what I
Correct.
meant. I was talking with the mom.
Yes, Taylor.
Later in the afternoon. He knows everyone has church. It's just
I can do that. That means you're going to be here till 6:30.
Life could
I'm
be
at
worse.
church from 7:30 a.m. to 8.
that way.
Oh, yo, wait, what?
Are you
I
at the
could
Grace
also do a
No?
Saturday mid-morning, but like starting at 8 or at 9.
Oh, wait.
Hey guys, so Haley legit all day on Sunday is at church. Could we do a Saturday morning starting at like 8 or 9?
If I have it right.
Okay.
Yeah.
I think we would do the 20th instead of the 21st.
Somebody else could be.
So, listen, hey, look at your calendar, come back, shoot me an email. Let's do that because I won't see you tomorrow. Shoot me an email to let me know if you can do say 8 or 9 on the 20th, Saturday morning.
Yep.
Okay? So look for that because again, we gotta go. So moving quickly, so let's get into it with Unit 7, inferences with quantitative data means. So as a recap, and this is the question that Haley had, I believe here, and so I'm gonna try to address this. Remember, right, with proportions, what standardized test statistic did we use? With proportions. So first off, I want you to look at your formula sheet. Where do you see the information on your formula sheet about the standardized test statistic?
At the bottom of the first page.
At the bottom of the first page, right? We have standardized test statistic. Notice they make it that is statistic minus parameter divided by standard error. Confidence interval, statistic plus or minus critical value times the standard error. So when we dealt with proportions, what standardized test statistic did we use? We used the Z. And how do we calculate that Z? What statistic went with proportions? P hat. What parameter went with it? P. Now I do want to point this out, right? All of inferential statistics is built out of what? Sampling distribution. So technically the parameter is the mean of p hat. Divided by the standard error is would be what? So sigma p hat, or sometimes we have to use S, right? Now, remember from sampling distributions, or look at the other side of the formula sheet. What is the mean of p hat? It's just p. What is the standard deviation of p hat? Square root of p times 1 minus p divided by, right? It's right there. If we remember, statistic minus parameter divided by standard error, standard deviation, there we go. The one thing to remember is if you don't have p, what do you have to use? P hat, right? The formula sheet is there, and I can go ahead and tell you this, looking at the free response, most of us did not look at the formula sheet when I asked y'all to determine if there was convincing evidence on that first free response. So, make sure you use your formula sheet. Now though, we are moving into means. It doesn't change. It's statistic minus parameter divided by standard deviation or standard error. However, what's going to be my statistic with means? Statistic is x bar minus, what's my parameter? Mu of x bar divided by standard deviation of x bar. And if we actually have it, this is what I need you to pay attention to. If we actually have the population standard deviation, right, then we can, so standard deviation divided by the square root of n, right, pulling it directly from here. Standard deviation divided by the square root of n, the mean of sample means is that. If we actually have the population standard deviation, what test statistic can we still use? Z. But we looked at that thing last week, the applet, right? If you don't have sigma, you have to use what? Well, if you don't, sorry. Instead of sigma, you would use S, right?
Yes.
It would still be sample mean minus mean divided by S divided by the square root of n. That population standard deviation does not change. What about S? It does change. So remember how some intervals were really wide and some were really short? And so our capture rate was wrong. So instead of using Z, we had to use T. We're going to go into more detail about what that T is. But remember, the T distribution just had different degrees of freedom, making it wider or narrower. Does that, just like that quick review, help that issue? Okay, so that's just a quick recap. But again, guys, use your formula sheet. Okay, so what are the 3 conditions for constructing a confidence? And by the way, all that stuff we talked about with the standardized test statistic applies for the confidence intervals as well. So what are the 3 conditions? I have random. What else? Independent, right? One subject cannot affect the next, right? So what do we check for that independence of selection?
10%.
That's my 10% condition. Last one.
The three parts of the central.
So, well, you're going too detailed to start. What do you have to have in order to use Z or T? Approximate normality, right? Approximately normal. And so remember, we talked about there being 3 different things now. And that's the 3 parts you're referring to. 3 different things that can make my sampling distribution approximately normal. What are they? The central limit theorem. As long as my sample size is what? Sufficiently large, the sampling distribution is approximately normal. As the sample size is sufficiently large. You with me, Peyton? Okay? What else can guarantee my sampling distribution is approximately normal?
Population distribution being approximately.
So the population distribution is approximately normal. But if we knew what the population distribution was, would we really need to do these inferential statistics? No. So what's the last one that I introduced last week?
Sample distribution. is
So-
roughly symmetric.
If the sample distribution is roughly symmetric, what is believable about the population distribution? So it's approximately normal. Notice it doesn't mean that the sample distribution has to be normal. If the sampling distribution is approximately symmetrical, we say it is believable.
A lot of approximating.
I know. Believable the population is approximately normal. Now, the reason why though, right, this is not math, right? This is a mathematical science. We are using mathematics, but nothing in statistics is 100%. That is the beauty and the frustration, okay? So, but if that sample distribution is approximately symmetrical, it is believable the population is approximately normal. And so we need that normality. Because what happens, Haley, if those conditions are violated? So one of those is about bias. Which one of those is about bias? The random one, right? But only the random one. But yeah, but why not? Like if I say I have a 95% confidence interval, what does that mean?
We're 95% confident that the interval that's not.
Okay. So that's that's interval, but let's go back to, and I should have said it more clearly like this. What about 95% confidence level? It's slightly different, but what does that level indicate?
That's a good question.
That's a great question. I'm glad I'm asking this question. Bryson, 95% confidence level, what does that mean?
It's the confidence that in a random sample that the true proportion will be called between the interval.
It's cool. I see why you're thinking that, but that's the exact major mistake students make. So pay attention, and I'm gonna, if it's not addressed by someone else, I'm gonna talk about why there's a mistake there. Logan.
Is it in the long run?
So remember, it's in the long run, right? It's not about one sample, it's not about one interval, it's about in the long run. So if I do many samples and construct many confidence intervals, how many of those intervals will capture the parameter? 95%. Remember on Thursday, last Thursday, how we did that applet and there was a lot of times where our intervals did not capture the parameter, right? But in the long run, when we use the t distribution, what percent of the intervals capture the parameter? 95%. The confidence level is the capture rate in the long run. Let me say that again. The confidence level is the capture rate in the long run. If I were to do many samples, right? So what happens if those conditions are violated?
The level means nothing.
Data
Say again?
The level means nothing.
The level means nothing, right? Like, if those conditions are violated, I wouldn't have said it that way, but I think that's a decent way to say it, right? If those conditions are violated, we have the wrong capture rate. And if we have the wrong capture rate, then what's the point, right?
Data sucks.
Yeah, right, our data sucks, our inference sucks, we don't want that, we want to have accurate stuff. So, we need to keep in mind that if those conditions are violated, then our capture rate is wrong, and that is a problem. If our capture rate is wrong, that's a problem. Okay, I want you using our formula sheets. What is the standard error of the sample mean? We can go to the textbook for this, but we should also think about those formulas on our formula sheet. So, what's the standard error formula?
S divided by the root of the sample size.
I'm missing something with that I want you to be aware of. I'm missing something that I want you to...
This is S sub X bar.
So the sample standard deviation of the sample means is equal to this, right? Because we got to remember, it's about a sampling distribution. A standard error is about a sampling distribution. And that's on the formula sheet, right? So, Haley, how do we know to use the S here instead of the sigma?
Because the sigma is for standard deviation and the S is for standard.
Beautiful, right? Sigma is for the standard deviation of the sampling means. S is the sample standard deviation of the sample means, right? So, that's the standard deviation,
Oh, yeah.
the sample, or the sample standard deviation of the sample means.
Yep.
And so what does that value mean? So first off, actually, is this formula on the formula sheet?
Yep.
Yes, most of the big formulas are, right? What does this mean though? How do we interpret this? So it is an estimator. I wouldn't say it's how we interpret it, but it is important to remember it is an estimator. What were you saying? An estimator of what?
Of sigma x bar.
So that's an estimator of sigma sub x bar. But what does it mean? How do we interpret this value? Let me ask you this, because this is important for review. What does S mean? No, just S.
Standard.
Oh, just standard.
But no, not S sub x bar, just S. Standard deviation of what? Of a sample, right? It's the standard deviation of a sample. But what is the standard deviation of a sample? We're forgetting what S means. Yes, standard deviation of a sample. But more importantly,
Given the sample size? N?
how do we calculate standard deviation? Is that on my formula sheet?
Yeah.
I believe it is on there. Look, so remember, is this descriptive statistics, probability, or inferential statistics? Descriptive. Isn't there a section devoted to descriptive statistics? So what is S sub x, or just S?
Hold on thing.
Okay, read it for me. What does it start with? Square root of?
1 over n minus.
Yeah, use the other one. I hate that one.
Alright, the sum of x and the sum of each x value minus the mean squared divided by n minus 1.
Thank you. Guys, what is x minus mu? That is the what between the value?
Distance.
That's the distance from the value to the mean, right? That's the, someone said a word, deviation, right? That's how far the value deviates from the mean, right? But what's the issue with the deviations from the mean? If I add them all together, I would get what? No. They would cancel out. Remember, guys, if I just do value minus mean and I add them all together, some are positive, some are negative, and the sum would be 0. So when I square it, I'm making them all positive, right? That actually gets really big. That's why I'm not doing this by hand. I'm using a calculator to do all this work. But what is this doing, right? Why are we dividing by n minus 1? When we say standard, that means typical
Average.
or average. So a typical deviation means difference from what? The mean. Guys, you cannot forget what these things mean. When I say standard deviation, it's a typical difference from the mean. So when I say S sub x bar, this is a typical what?
Distance from.
So it's a typical distance of what?
Of x bar from mu. of X bar.
right? It's a typical distance of the values from the mean, right? And we're talking about a sampling distribution. The values are X bar. So when we say standard deviation, you've got to remember that's a typical distance from the mean, a typical difference or deviation from the mean. It's standardized, it's averaged, right? That's what we mean by standard deviation, is an average or typical distance from the mean. From here, we want the formula for a confidence interval for a population mean. All right, so when we're talking about a confidence interval, what type of statistics are we referring to? Descriptive, probability, or inferential? Inferential, so I'm going to go down to 3. We want to notice that. Anyone see somewhere I could start for my confidence interval?
Statistic.
Sorry, let me rephrase that. Just somewhere on this formula sheet, what section I'm going to be looking at.
Like confidence intervals.
Oh, there's literally a section for what? I'm not trying to, I know it's like it's too easy, but no, I'm like, if I'm looking for a confidence interval, what am I looking at? Right here, my confidence interval. Alright, so how do I do confidence interval? It is a statistic
Plus or minus.
plus or minus critical value
Times the standard error of the statistic.
times the standard error. Now, this is going to draw on some previous things we talked about. Alyssa, when I do the critical value times the standard error, do you remember what that's going to be called? I think this might have been one of those days you missed. So that probably. Peyton, do you remember what the critical value times the standard error is called? Say again? No, just this piece. The whole thing is the confidence interval. Just this piece. So if we don't know this, one, it's on our FREER models. We got to know this. It was in our notes. We got to know this. Josh, what was it called?
Margin of error.
Guys, the standard error times the critical value. The typical difference or distance is called that margin of error. It's how far we go from our statistic to either side. Sorry, I forgot to review that, I guess, but margin of error. We got to know margin of error. Now, if I'm trying to do a confidence interval for means, Peyton, what statistic do you think I'm going to use? Any guesses where I could look at on the formula sheet to figure this out? No, because that's standardized test statistic. I'm looking for a confidence interval. I want a statistic. Peyton, it's built on sampling distributions. Flip the page over. Do you see anywhere that it's talking about means? Is it going to be this top section here? Okay, why not? Hey, why, guys? Hey, why is it not going to be this top section? Okay, so you don't see X bar. Also, look at the very top up here. It literally says this is a sampling distribution for what? Proportions. But if I look at the next section, what does it say? For means. Look where it says random variable, where it says that'd be your statistic. What is our statistic? Look again, that's a standard error of the sample statistic. So that's standard error, S. What is the statistic? It's in that formula, but what is the statistic? Okay, we got to know this. Peyton, I'm going to come back to you in the future on this. I need you paying attention. If I'm looking at means, let me ask this question. Joseph, what is the parameter for means? Mu. There's my parameter. Lexi, what is my standard deviation. What is my statistic for means? Mu is my parameter. What's my statistic?
Forgot what it's called. Isn't that it? X bar.
Guys, sample mean, population mean.
Okay.
Sample mean, population mean. Sample mean, population mean. A statistic is the sample version of it. So Peyton, what's my statistic? Okay, Peyton, it's one of the two things on the board, dude. Peyton, we gotta know, parameters are for populations. Statistics are for samples. You gotta know, parameters are for populations, statistics are for samples. That's important, because I'm talking about proportions, what's my statistic? Is it P or P hat? Statistic is for the sample, proportions, parameter is P. We gotta know the difference there. So what is my statistic, Haley? Yep, X bar. Plus or minus. Austin, what critical value are we gonna use?
We're gonna use the, just the whole formula.
But what's just the critical value?
Oh, Z.
Z? Were you thinking Z?
Star.
What'd you say? What'd you actually say? T. Which one is it? Is it Z or is it T?
I would use T.
So which one?
T.
I forgot
It's
the
T
time.
when you only have what?
The sample standard error.
Right?
I would use it
It's
as-
T when we have the sample standard deviation. It is Z if we very unlikely have the what? Population standard deviation. Huh? We gotta remember, guys. And notice the standard error is on that formula sheet, but you've got to know if we're using Z or T, because it changes.
Right, so we use T when we have the sample.
Correct. If you do, a better way to say it is, if you don't have the population standard deviation, you use T.
What
Just-
about the means?
Huh?
What about the means is semi?
Well, these are for means. This is a confidence interval for means.
Oh, I got you.
Right?
Yep.
And so if I have the sample standard, if I have the population standard deviation with that sample mean, I use Z. But it's very unlikely to have sigma if I don't have mu. Right? So with sample means, or confidence interval for means, I'm almost always going to use that. But, Peyton, I need you to look and recognize where it uses the words, that's parameters, right? There's standard error, but you see right here where it says X bar? That's my statistic. Okay. So, we got that confidence interval. Notice again, is that entire formula on the formula sheet?
No.
No, but this piece is, and the pieces of this are. Right? So on your notes here, once again, and this is what I noticed on the test is, we did not use those pieces of the formula sheet and build the formula that we needed. I cannot tell you how many times I saw students tell me that the standardized test statistic, so close your ears, Joseph, and Leah's out of here, we're good. When they told me that the standardized test statistic was just this.
Are you not covering your ears?
Because he hasn't taken the test yet. Y'all told me that this was the standardized test statistic. Is that alone the standardized test statistic? No, that's just the what?
I feel like it's making it loud.
That's just the standard error, guys. We gotta use the formula on the formula sheet. We gotta know what to substitute in. So, the generalized formula is there. We gotta know what to plug in. Alright, so we've got the NFL games on TV last over 3 hours, but how much actual game time is there in a typical NFL game? I think they've actually passed some, I know with baseball they've recently passed some rules. Have they recently passed rules on NFL to shorten the
No,
length? Not yet?
They just
Add
add
tackle
tackle
rules.
Yeah.
Like, to try to.
Football's lit.
Okay.
Make it longer.
So,
Why even play football?
how much actual game time is there? And so we have these researchers that investigated this question as part of a sports analytics class at UT Austin. They carefully watched a random sample of 7 games from the 2019 NFL season, recorded the amount of time, yada, yada, yada. Here are the game time values in minutes, excluding any overtime periods, right? So just the time when the ball was snapped to when the referee blew the whistle. Construct and interpret a 99% confidence interval for mu, the mean amount of game time in all of 2019 NFL games. So, first things first. Based on this language, Ashton, what do I know I have to write out for this?
Confidence interval. So I already know I'm gonna need that statistic CI formula right there.
So, let's back up for a second. I'm not saying you're wrong on that, but I am saying I want a skeleton of what I need to write to get full credit on the AP exam.
State plan to conclude.
There we go. Construct and interpret. State, plan, do, conclude. We've got to have the 4 pieces. We've got to have the 4 pieces. For a hypothesis test, what's going to go, and this isn't a hypothesis test, but in a hypothesis test, what's going to go in there? Hypotheses.
And your p-values.
The what?
Define your
Well, p-value is going to come in the do section, right?
Well,
So
no,
we haven't
p-values,
actually-
but defining where you can use them.
Oh, so your parameters, say again? And your significance level, right? But when I'm doing a state for a confidence interval, what do I need?
Context.
So I need context, right?
99, or like.
And the confidence level, right? So, developing, or we are developing a 99% confidence interval. Now I need you to be careful on this context. For what? So I need someone to tell me what.
For the true amount of time.
Let's be at that.
Let's, so I noticed you said amount of time. What's a keyword we could use there for the type of confidence interval we're trying to do? True mean, right? That's what we're looking at as means, right? I'm not looking at proportions, because I actually, in my head, caught myself saying proportions here. We're not dealing with proportions, we're dealing with means, the true mean time. What other do I need in this context?
That. I don't know how you can say that.
You just gotta get close.
Game time.
So true mean time
Of actual.
Of gameplay.
of actual gameplay. Is there anything else?
And all 2019 NFL games.
Oh, there we go. Actual gameplay for 2019 NFL games. Why is it only 2019? Why is it not all NFL games?
Generalize it, because there could be like different rules.
So different years, there might be different rules. Remember, where did our sample come from? It was only from what years? Only 2019, right? So please pay attention to these facts, right? When we talk about our population, we have to pay attention to where did our sample come from. It was only the year 2019. So, plan. What's our plan going to be? Okay, so our formula, or at least the name of the formula, one of the two. And what else do we need under plan? We need the type of inference procedure and the conditions, right? So type of inference procedure and the conditions. Every time under plan, Peyton, what do we need under plan? So the formula or the name, so the type of inference procedure, and what else? There's a C word that we've been using. It's the most important part of plan. Conditions. You've got to have your conditions there. So, what would we call this?
Confidence interval for means.
Okay, so what type of confidence interval? Because there can be two different ones. So there is a one sample T interval for means. But wait, why are we doing a T interval this time?
We don't have cities.
We don't have sigma, right? One sample T interval for means, cool. Yeah, that could be it. Now let's think about our interval. So you go to that formula sheet if you don't remember the interval, right? What's the first part of confidence interval? Statistic, right? So, Peyton, what's the statistic for this formula? We're doing this for means. X bar, there we go. Plus or minus. Bryson, what's our critical value?
It would be T, right there.
Thank you, T star.
Okay.
Or
That
just
answered my
T,
question.
right? I'm okay with you just saying T. Times, what's going to be my standard error?
S sub X, S over
So S sub X bar, so I'm just going to write S divided by square root of N. That's my confidence interval. Okay. Austin, what do I now need to check?
Conditions.
What's my first condition?
Random.
Was randomness there?
Yes.
Right, so,
Just random sample.
yeah, I'm looking for that language,
Third line. Third line.
right? If I were you, I would circle it and check mark, right? Because they want to know that you understand it is random, so show that evidence. Alyssa, what's another condition I need to check? Okay, so maybe the central limit theorem, but what does the central limit theorem say? Something about the sample size. If the sample size is sufficiently large enough, the sampling distribution is that sample size sufficiently large enough?
I don't think so.
Typically we need what sample size? 30, right? So can we use the central limit theorem here? No. Do we know the population is approximately normal? No. So what do I need to do?
Figure out if the sample is symmetrical.
So I need to look at the sample distribution, guys, and you have to do this on the AP exam. So how are we going to check to see if that sample is roughly symmetric?
Google.
No.
Make a dot
What
plot.
about it? Calculate.
Yeah, how are you going to make a dot plot?
Crazy.
I mean, you could just-
Okay, so just make a dot plot of those points.
You could.
You could. You know it's a better way to do it?
Good.
On the calculator.
I would say I would go to a calculator. How about you pick up a calculator? Let's do a page. Where am I going to put my data in to be able to check this?
A
A
table.
list.
So list and spreadsheets. Make a page. Go to list and spreadsheets. Make sure. Remember, add a page. Oh, you're saving. Don't ever save it. You don't need to save it. Okay. So just list and spreadsheets, guys. Hit escape, Logan. Hit escape. Hit escape again. New document. And don't save the old one.
Oh, no, no.
Okay.
I'm locked in.
So, what needs to go here in this column, y'all?
Of your time.
The values, right? So, also, don't forget we have to label this variable. So, what values would I put in?
Minutes.
So, minutes or time, either one. But yeah, I would do minutes. That's a good one. And so, what's the first data value?
15.43.
What was it?
15.43.
15.43? That seems so short.
You seem
Uh,
so short.
So, type I am very short.
Where do we type in the name?
Remember at the very top where it has the letter for that column.
It says it cannot accept change, invalid input.
Oh, because you just put MIN. That calculator understands that as minimum, so type out minutes. Yeah. Or you can
Can I
put
do-
time in.
M-I-N-S?
That could work as well.
Okay.
I would just type, I would take the extra 5 seconds to type out the full word.
So,
I don't have it.
No, not that much time.
There's a T.
Guys,
Gotta maximize time.
guys. I promise you, if I'm telling you you have time for it, you do. Slow is smooth, smooth is fast. Be attentive to the details. Okay,
X.
be attentive to the details. All right, so what are we doing from here?
From here, probably need a second column.
No. What do we need to do? We're trying to check the what?
Why do you keep saying sit that there?
Symmetry.
Not menu yet. Hey guys, what are we trying to do? Okay, we're trying to graph it, right? We're trying to find out if the sample is roughly what? Symmetrical. We don't even need normal for the sample. Hit escape.
Just go to
Okay.
statistics.
So guys, we need to graph this. What do I need to do to graph this? I'm going to go to Control Doc. That's going to allow me to add a page. What type of page do we want to graph? Add data and statistics. And this is why we had to name it. If you click to add the variable, we can click on minutes,
Would you on the y-axis?
x-axis, always the x-axis. If it's one variable, it's x-axis.
Wait, I'm confused.
Now, can you make that dot plot? Sure. If I were you though,
Instagram.
no. What's the easiest graph to sketch out?
Mosaic plot.
No way.
Yeah, box plot's super easy, guys.
Plot.
I was
So go to menu,
clearly not wanting to work.
change your plot type,
Looks pretty
do a histogram.
There we go.
No, not histogram. I literally said box plot. I know what I'm saying.
Pie chart.
Okay, so
Oh, shoot.
you need to sketch out that box plot on the problem under the plan section.
Yeah, it looks pretty normal to me.
I'm trying to.
So we're not doing the dot plot, we do a box plot?
Because you went, I would do a box plot. You can do a dot plot if you desire.
I'm running out of
Data and statistics is where we graph data. Okay,
Do I have to like label like axes or something, just draw a sketch out?
I would do a quick sketch of the axes,
Oh, that's okay. I'll do it.
right? So axes, 15, 16, 17, 18, 19, 20. I am not going to do the full procedure of sketching a graph though, because I just need to show that this is approximately normal, or actually approximately symmetrical.
It really isn't though.
Yes.
Ah, say that again.
It isn't.
It isn't really. So here's the crazy thing, and I hate this. The AP exam doesn't really care if it's really symmetrical. It's just if there's not heavy skewness.
Oh no, it looks pretty
What?
smart.
Looks pretty skewed.
Looks pretty skewed to me.
But-
the same thing.
No,
It's
no.
not skewed enough.
Look at
What
the.
is?
And if it
What's wrong
is,
with it?
listen, hey guys, listen. On the AP exam, it will be very
I didn't
clear if it is too skewed to continue with the procedure. But also on the AP exam, if they want you to do an inference procedure, how often do you think it's not gonna work?
Never.
Almost.
Yeah, almost never. I've never seen it happen. So, in this context, we would say it is not heavily skewed, so
Good enough.
it is close enough, right? It is not heavily skewed, so we believe the sampling distribution could be approximately normal.
Would you still put that under central limit there or not?
No, that's not central limit theorem.
Well, like-
Central limit theorem is
I know it is, but what would you put there?
just the sampling distribution is approximately normal, because that's all we care about. So, we would point to this, right? Not heavily skewed. So, approximately normal, or I should say, so sampling distribution could be approximately normal. Any other conditions?
10%.
10% is 7, less than 10% of all NFL games?
Yeah.
Yeah, definitely.
Unless you're in
So we can now continue. Alright. Let's do the do section. Do the do. Right? So, for the do section of this, we actually need quite a few things. We don't have a lot of this information yet, do we? So what do I need, what am I going to do before I can really even do the do section and at least write it out? So, two things. Go back to your data, guys. What do I need from this data? I need the mean, I need what?
Yes.
I need the S.
And you got a number.
I also need what?
The T-star.
I need the T-star, right? So how can I find that mean and that S quickly?
Calculator.
I'm gonna use that calculator, yeah, menu, then what? Statistics. Stat calculations. Yep, so menu, statistics, stat calculations, one variable. One list, and what's my list? Yeah, next one list, so what are we gonna put there though? Minutes, okay? So run that data. Do we now have S? Do we now have X bar? Yep. Man, so one, I'm glad we did this together because I want us to review this, but did anybody notice anything that might have made my life easier? Nobody? Go back to menu. Go back to statistics. No one sees anything?
Oh, the confidence.
Holy crap, there's a confidence interval option there. Man, that's wild.
Wait.
And then where am I gonna go?
Three.
Understand.
Which one?
Two.
T interval.
So the sheet below.
Yeah. Now, hey guys, I need you to pay attention to this. Right here. I need everyone to pay attention. It asks for a data input method. So I want you to notice there's two options, data or statistics. Do we have actual data or do we have statistics? We have actual data, don't we? Now we do have some statistics, right? We do have some statistics now once we did that, but if we hadn't done the one variable stats earlier, we wouldn't have had the statistics. We could have just used what?
The data.
Data. Hit OK. Alright, so what list are we going to use? Minutes. The frequency is 1. The confidence level? 0.99. First result column is D.
Whoa, no way.
So this could be.
What's your grade? What's your C level?
Say again?
What's your C level?
Look at the problem in the notes. Say again?
We'll survive.
Couldn't do this a couple weeks ago when we did
It
proportions.
doesn't even say that.
Because we didn't have statistics then. This works for means, but I have shown you how to do confidence intervals in the calculator, haven't I? And hypothesis test for proportions in the calculator. We just didn't have raw data. Now I'm going to show you something else in a second, Bryce, to help this click. So, hey guys, right here, this under the do section is now where I can grab my information. What is X bar?
17.71.
Yeah, but 17.71. Does anyone see the T anywhere? Let's look.
Why is that give me a T, but it gives me a margin of error?
Yeah, it doesn't give me a T, but it does give me a margin of error. So realistically, could I just do plus or minus 2.83?
Yeah.
Yeah, I could. That's my margin of error. That's not what I'm going to recommend, but you can 100% do that if you don't remember how to get the T star and how to get S and the square root put in. Okay.
Wait, so is do you find T just like you do it in Z? What's the difference?
I'll show you in a second. So what is my lower and upper?
Where did I get 2.8?
If you look ME right here, that's my margin of error. It's given, isn't it?
Yeah.
Mine's coming out of like 1.8.
Check your data. You might have plugged something in wrong.
I guess like they are.
Actually, is it the margin of error or S that's 1.8?
Oh,
shit.
margin of error.
Okay, check it. Unless I typed something in wrong. Did other people get 2.83? Okay. Alright, so what is my confidence interval? It is 14.89 to
20.54.
20.54. Okay. And there's my confidence interval. Now I'm going to show you a couple other things in a second, but that's my do. I'm done. Now I'm going to answer Deacon's question about how do we get T star.
Please.
Yes. Because if you're asked about this on the multiple choice specifically, you got to know this. So remember, a t-distribution, it's a whole lot like a standard normal, it's a whole lot like a z-score, right? It has a mean of 0, and we're going to talk about a standard deviation of 1. It just doesn't follow the empirical rule. But what area should I be shading under this curve? So I have a percent, so I need area.
Oh, got it out.
Now 99%, right? Is it that 99% is less than the value, or what?
In between.
So remember, 99% is in between, right? So can I put that 99% into the calculator?
No.
No. So remember, what I would do, if it's 99%, that means there's 1% in the tails, right? So what area,
There's 1% of the tails. What?
the 9%, 99% it also means 1% in tails.
Oh, I was like, what?
So what would be the total area less than T star?
0.005.
So area is 0.995, right? 1% in the two tails, so I split it in half
Yeah.
to get what is less. Deacon, we did this with z-scores, man.
Okay, it makes sense, yeah.
Okay. Remember, 1% in our tails.
Yep.
So I'm only going to include one tail. So let's pick up the calculator. What are we going to put in?
Menu.
So now I will point this out. What page do you need?
Calculator.
You need a calculator page. So add a new page for calculator page.
Do we need the other ones, Joe?
Yeah, I just add a calculator page. Leave all the other stuff in there. So menu. Where are we going to go from menu? Statistics or probability, both have distributions there. And notice, right? So distribution, so we're doing T. Do we want to do inverse or TCDF?
I say inverse.
I would say, so remember, if you're not sure, just go to one of them and check it. If I do TCDF, what does it ask for? A lower bound and an upper bound. Do we have the bounds?
No.
So am I doing a CDF? No, I've got to be doing
Inverse.
the inverse
Yeah.
or inverse T, right? So use the information there. So what's my area? 0.995. What's my degrees of freedom? Wait, my sample size was 7.
Okay, so this
N minus 1.
Ah, my degrees of freedom is n minus 1. So my degrees of freedom is 6. So there's my T. So T, my critical value is 3.71. Guys, if you're not sure about this, you need to go back to those earlier notes. Nope, because we're not doing the interval. We're looking at the distributions right now to find the T. Yeah.
What is the purpose of the
Right? Okay. So, if I was doing my interval, I would do the 17.71 plus or minus 3.71 times, what was S? I think it was a 2.02 divided by the square root of 7. Now, I'll point this out. Josh pointed out this fact earlier. Do we have a ton of time on the AP exam?
No.
So if you're in a time crunch, is it okay to use just the margin of error from the calculator?
Yeah.
Yeah.
100%. Now,
So that's fine, that works the same?
so this right here is my margin of error, which would be the same as this margin of error. Okay? Now, one last thing I want to show you, because Bryson, you're like, man, Mr. Kenny, it would have been nice if you'd showed us this in the past. Look, menu. If I go to statistics, remember, there's confidence intervals right here, Bryson. Right? Okay? And so, remember how we did 1 and 2 prop z intervals. I did say use the calculator for the actual work. You got to set it up. You got to know how to do the procedure. But use the calculator for the actual work. Right here is t interval. All right? So if I go to t interval, notice again how it asks for what input method. This is only for means that it'll do this. The one thing I do like is, I like the way that this is set up better, because I can more easily see all the information right there. It's the same exact values though, isn't it? Okay.
Why does empirical not apply to?
Only for
Because remember, it's not a normal distribution. It's symmetrical, it's bell-shaped, but it's not the standard normal curve.
Mr. Green, how'd you find the standard deviation on the calculator?
You mean under the, when?
The
It's-
margin of error.
It's, no, the standard deviation was right here,
Oh, okay.
right, SX?
Yep.
So, Bryson, remember, and so one, and we'll talk more about it later, but the T distributions have more spread than the standard normal curve, and so there's more area in the tails and less in the center. So it's not going to follow the empirical rule.
Is that the visual, like, would you just have to know T from Z?
I mean, that's why we're using T. You're not gonna have to visually know it. So like, let's say this is Z, then this could be our T right here. You see how it has more area in the tails? So that's the big thing. That's why it doesn't follow the empirical rule. That's why it's not a normal distribution. So T is gonna be shorter and it's gonna be wider, because remember how we need to spread those intervals out more,
Yes, sir.
right? Okay. So last thing, we gotta interpret. Bryson, what do we start with on the interpret piece? So with something. How do we start to conclude the interpret piece? With what?
9.95 or 99. You get where I'm going.
No, you gotta know where you're going. You got the AP exam. I know how to do this.
Do you?
With 99%.
Is it not the 0.5?
No, because remember, that's what we had to do to get the T score, right?
I got it.
What's the confidence interval?
99.
So with 99% confidence, what? What comes after the confidence? The interval. Does what? What interval?
14.89 or 20.
From 14.89 to 20.54 does what?
Captures the true mean.
Captures the true, bless you, mean
Of game time in 2019 NFL games.
for football, for NFL games in 2019. One of the big things I'm going to say is this. Our conclusions were rough on the free response, and that's because we did not do the state portion well. It is hard to do a good conclusion without a good state at the beginning. Okay?
So for state, every time you fully write all that out, or can you just like for the hypothesis test, I've just been putting the hypotheses and
So remember, for the hypotheses, everybody needs your attention on this, guys. Hey, on hypothesis test, you need to put your hypotheses, you need to put your significance level, but you also need to define the parameters, which is essentially what I'm doing here, right? That's defining the parameters, okay? Can you use your calculator for the entire do step?
Can I show you where it's done?
So you can, but if you make a mistake, you're screwed, right? So show the pieces to that, right? Show the pieces of your interval, because that's going to help make sure that you still get the credit. Show the formula, show things substituted in, and you're going to get that credit still, even if you make a small mistake. Because would it be easy to type a number wrong into the calculator?
Yeah.
Yes. Is that what ended up happening?
Yeah, I didn't change the confidence level.
Gotcha. That can do it as well. All right. So are there any drawbacks? Yes. You make a mistake,
You're screwed.
you're out of luck. Really quickly, what factors affect the margin of error for a confidence interval?
Sample size.
Sample size. What else?
Standard error.
Standard error.
Critical value and the T.
And the critical value. Well, and what defines the critical value?
Confidence level.
The confidence level, right? So, do not forget, all three of those things are going to affect the margin of error. Say again? Sample size, standard error, the CL, the confidence level?
No, I was asking for the standard error. I couldn't do that.
Gotcha. So, How does the sample size affect the margin of error?
It'll decrease it when it goes up.
So when you increase n, what happens to your standard error?
It goes down.
It decreases, right? And so really that we shouldn't even necessarily need to worry about the standard error. Well, standard error decreases. We can also say this about the standard error. When you take different samples, what happens to your sample standard deviation?
It increases the population.
Why does it change? Because of,
This is for sample. Variability.
right, there's always sampling variability. And so because there's that sampling variability, that's why some of those intervals were way wider and way shorter than others. Okay, so Alyssa, when we increase that confidence level, what happens to our interval?
Let me see, confidence level.
What, if I want to be more confident that I capture the parameter, should the interval be wider or smaller? So, and this is actually, I guess I should rephrase this because it can be a little confusing, but think about it this way. If you have a smaller interval, it's more precise, sure, but is it more likely that you captured the parameter? No. So if we want a higher confidence level, wider interval, right? That's why our T will be bigger, right?
Well, they're too wide and it's just slip. It's not.
But we're more likely to capture the parameter, but it's also, yeah, a little bit less information.
So it's
Right.
confidence level goes
Because like, I'm 100% that 0 to 1 captures the true parameter of the sample proportion, or the population proportion. That doesn't really tell me anything, does it? Right. So the wider it is, the worse off we are. Okay. There's some practice homework questions there.
The wider.
Okay. Next page. We need to move quickly for this. So, what are the mean and standard deviation? So now we're moving into a sampling distribution for what?
Difference in means.
For a difference of means. I like that language, and for 2 samples is what Deacon was saying. Okay. By the way, are there formulas that are on the formula sheet for this?
Yes.
Yeah. What is the mean of x bar 1 minus x bar 2?
That's the mean of x bar 1 minus the mean of x bar 2.
And so remember, we've studied this in the past, where if we are combining 2 random variables, right? We're combining the random variables through subtraction. It's just the difference of the 2 means. But what, Haley, is the mean of the sample mean 1? It's not the x bar, it's the, because remember, the mean of all the sample means is the population mean. If you look at that formula sheet, doesn't it say mu1? It does, I believe. mu1, right? They even skip this middle step, but it's mu1. So what would be this one, Haley? mu2. And no, not the Pokemon, but
Finally understood something.
all right.
I'm always school guy.
So then, standard deviation. I don't know. All right, sigma or S? Hey guys, should I use sigma or S more than likely? More than likely, we're gonna have to use S.
Yeah.
Now remember, can I add and subtract standard deviation?
No.
No.
Let's go variability.
You should factor variance.
Remember, it follows the Pythagorean theorem, right? I can't add the standard deviations, but I can add their variances. And even though it says minus here, variability only what? Increases. So what am I going to do here? Add. So remember, you cannot add and subtract standard deviation. You have to do the variances. So, is equal to the square root Now, we just looked at this. What is the standard deviation of the sample means? Because S sub x bar is S divided by square root of n. But if I need to square that, it's going to be S sub 1 squared divided by n1 plus S sub 2 squared divided by n2. Is that the, isn't that the formula they have on here? Yeah.
I don't even know how you got it.
Okay, Deacon.
Oh, never mind, I lied.
Okay, so 1 is on the formula sheet, but 2, Deacon right here.
It is on the formula sheet.
I know. The mean, or the standard deviation of the sample means is S divided by the square root of n, right?
Yep.
But I'm not adding the standard deviations, I'm adding their
Variances.
variances, so I gotta square both sides. So that's gonna be S squared divided by the square root of n squared is just n.
Yep.
So that's where that formula is coming from. I will be just sending an email of what you need to do for the e-learning day. Juniors, I apologize, but y'all are gonna have the second half of the day and we got to keep going. So I'll shoot you an email of what to do.
That's unfortunate.
I'm not.
Okay, then I will shoot you the email and I need